Assalamualaikum warahmatullahi wabarakatuh and good day to each and everyone. Um, this is EE once again. This is EE224. No? So, I'm your instructor, Engineer Hanif Makaindig. Okay, as what we have done in our last meeting, we have just discussed the fundamentals and properties of a diode, okay, as a electronic components. Okay, so this time we will be tackling about the basic operation, the characteristic of an ideal diode, the comparison of Si or silicon and germanium semiconductor diodes, and the operating condition. We have here the Zener diode and resistance levels diode. Okay, so now, so diodes is simplest. This is the simplest semiconductor device. Okay, so it is represented based on this diagram. So if you will see this diagram, this is called as diode. Okay, so why it is called as a diode? It's because it has only a two terminals, and and it it operates same as switch. No, it is a two terminal device. So these are the basic operation of the diode. So ideally, it conducts current in only one direction, and it acts like an open in the opposite direction. So that's why a diode can be considered as a switch. No, it's because we can operate them um, continually, no, in a um, uh, in a direction of the current, and we can uh, consider it as a open circuited if it is if it is in opposite direction, same as what switch is. Okay, same as what properties of the switch is. Okay, so we have here, if it is in direction of positive and negative, it is same as a short circuited, so the current will freely go from this terminal here is papunta dito sa terminals, and it is a continuous condition. For the reverse bias naman, or the potential difference is in opposite directions. We have here negative and positive dito. So we can consider that one as an open circuited. So we have the current is equals to 0. Okay, so we have here this one. So open circuited siya. So yan lang actually yung basic operation ng diode. Okay? So characteristic of an ideal diode. So we have here, meron tayong tinatawag na conducting region. Okay? So for that conducting region, okay, so if you have, as I have said kanina, kung meron tayong forward bias na diode, um, so the current conducting freely from one terminal to the other. Okay, and then if it is not in a forward bias basis, the current will not go from one terminal to the other. So we have here, look at the vertical line, no? So if we take the look on the vertical line, in the conduction region, ideally the voltage across the diode is 0, no? So here, this one, no? This is the conducting region, so we can assume that this is a open short circuited. Therefore, the voltage here is ideally equals to 0, and the current is infinity, no? And the forward resistance RF is defined as RF over VF over IF. Then the diode acts like a short circuited. Bakit? Kasi if we take the voltage, no, to be equal to 0, then divide that one by the any number, so that would be approximately equal to 0 din. So ibig sabihin this is short circuited. Now, if we take a look on the horizontal line, this one, okay, so which is a non-conducting region. So ideally, all of the voltage is across the diode. Okay, so the voltage here is maximum, no? So across the diode, concentrated across the diode, and since it is a open circuited, okay, for that condition, so the current should be equal to 0, right? And the resistance across that is defined by the Ohm's law. We have R is equals to VR over IR, but since yung current natin is equals to 0, So this diode acts like an open circuited. Okay. So somewhat like it has a resistance of infinity. Okay. So yun. So we have here a common materials used in development of semiconductor devices. We have the silicon and germanium. These are the common elements that are used in constructing diodes. No, so below here, this table here suggests uh, what are the difference between the two. For the silicon, so we have here the characteristic, and for the germanium, we have also here the characteristic. Okay, so basically, the most used one is the uh, germanium. Okay, so it's because it has a lower, no, they have different uses actually. No, we cannot say how does they use frequently. No, so they have different uses uh, with regards to their characteristics. Okay, based on their characteristics. Okay, kasi some of them has the disadvantage, and some of them has the advantage naman. Okay, so we have here a graph of a how does they operate for the germanium, for the silicon. Okay, itong red na to na graph. So as you can see here, um the diode required first 0.7 volts in order for it to conduct a current. No, so first kay zero muna yung kanyang current, then after it reaches the voltage of 0.7 volts, it will conduct. No, and for the germanium naman, okay, so meron tayong negative value of the current, and after it reaches a 0.3 volts, it will reach a maximum value. Okay, so these are the basic or these are the characteristic and graph of the germanium and silicon. So dito tayo sa operating condition. Sa diode kasi meron tayong tatlong condition. We have the no bias, which is there will no be a connected voltage across the diode. So ibig sabihin the connection is stable. I have just shown this one from our previous discussion, no, na pag wala tayong external na voltage, there will no be a flow of the current from one terminal to the other. And meron tayong tinatawag na forward bias. Forward bias naman is if we this condition is happen when we apply a voltage across the diode. Okay? So meaning of the forward bias kay short circuited, no, it means that it reaches enough the voltage of 0.7 or 0.3 for the diode to fully perform its short-circuited na condition. So it has a current. Okay, so ito yung mga properties na dito, no, just as what we have said here. Okay, so ito yung forward bias, ito naman yung um, reverse bias. Okay, so yun, reverse bias. Okay, so yun, same as what I have said, no bias, there is no there is no current and there is no voltage, so kwan siya, no, stable. And for the forward bias, there is current na, no, pero voltage is equals to approximately equals to 0.7, or for the germanium approximately equals to 0.3. And for the reverse bias, uh, there will no be a current, no, and the voltage is concentrated on that diode. Okay, so it acts like a open circuited. So we have here an actual diode characteristic. Yung kanina rito, this is just an approximation on how they are operate, but this is the actual operation. So as you can see here, for the silicon, this blue graph here, it needs 0.7 volts first to conduct a short-circuited na condition. Okay, then for the germanium naman, it needs 0.3 volts for it to be able to conduct. Okay, so now, so we have here the so-called Zener diode. What is Zener diode? A Zener diode is a diode operated in reverse bias at the peak inverse voltage called the Zener voltage. Okay, so for the Zener diode, it has a characteristic. This is not an ideal diode, no? So, pag Zener diode kasi, ito yung mas common na na-encounter natin. So, it has the so-called a peak inverse voltage. So, what is that? Peak inverse voltage is somewhat approximately equals to 1.8 volts. No? Anong nangyari pag ganyan? Pag nag-reach na siya sa peak inverse the diode, bumababa yung kanyang current. Okay? So, the diode is reverse bias condition at some times. So, at some time of when the reverse bias voltage is so large and the diode can be breakdown. So, if you will let this zener region here to happen, okay? Then the reverse current increases dramatically, no? This maximum voltage is called the avalanche breakdown voltage, and the current is called a avalanche current. Okay, so here. So, negative yung kanyang current. So, resistance level. So, semiconductors act differently to DC and AC current, no? So, there are three types of resistances. We have the DC or static resistances, the AC or dynamic resistances, and the average of or AC resistances. Okay, so we have here different discussion about that one. So by the way, that is just a basic idea of the resistance. So please read about that one. Kasi nga in here we are considering those characteristics of diodes. Okay, so if you have any question about this discussion regarding on the basic operation of diode, please uh, let me know, no? Okay, then of course yung diode testing sa baba, yung importante rin yun siya. So pakibasa na lang din. So this is based on actual talaga na situation. Okay? So please read this diode testing here. So once again, if you have any question regarding on these topics, please ask it to me right away para wala tayong problema regarding these topics. Okay? So I think that's all. Assalamualaikum warahmatullahi taala wabarakatuh and good day.